Hello friends, very good morning. Myself Dr. M.H. Chennaiya. In this video, we are going to learn about obtaining the sectional views and development of a hexagonal pyramid which is resting on its base on HP with one of the sides of that base perpendicular to VP or normal to VP, and it is cut by a section plane which is normal to VP and inclined at 50 degrees to HP, passes through an edge of the base. So friends, first of all, let us obtain the top view, the hexagon of side 30 millimeter, and mark on this the corners, namely A, B, C, D, E and F. These are the six corners of the base, and we will transfer all these to the front view and obtain the front view with height is equal to 60 mm. So I am going to write 60 mm here as the height of this pyramid. And friends, let's see how it is cut by section plane. Before that, let me transfer these points. A dash, B dash, this is D dash, E dash. Center is C dash, F dash. This is O comma O1, where O is the vertex of the solid. O1 is the center of the base. So we'll call it as O dash and O1 dash. Now friends, the section plane SS is passing through one of the base edges. So in this particular front view, you can see AB can be considered as one of the base edges, and DE can also be considered as one of the base edges. Now the section plane can be taken either inclined to the right, passing through AB, or inclined to the left, passing through DE. So let us say we are passing the section plane through this point A dash, B dash, and inclined at an angle of, say, 50 degrees to HP. They have given in the question, this is 50 degrees. And this is the section plane. Yes, I am going to show it dark, passing through the edge here. And friends, after marking the section plane SS, passing through AB, let us see what is a portion of the pyramid that is retained for development. So this portion below the section plane is retained for the purpose of drawing the development. And now friends, the section plane is cutting the solid at these three places. There are 2 points for this where it is cutting OD and OE. There are 2 points here where it is cutting OC and OF. It is passing through A and B. So let us commence from A and B. The section plane SS is passing through A. It is also passing through B. So you get 2 points. Next friends, it is passing through this OD and OE are cut here. So let us write a vertical line through that so as to cut OD and OE. So this is 1 point, this is the other point on OD and also on OE. And friends, the central one, that is OC and OF are cut here. But OC and OF, you find them vertical in the top view. Hence, to obtain that, friends, let us draw the left hand view of the pyramid by looking in this direction for the given height of 60 mm. So I write a horizontal line, mark the center of this, and transfer all these points to that. That is, you got F first, that is F double dash in the end view, last is C double dash, and we have to join them by straight line. This is one, this is the second line, and you have got AE and BD. AE is here, so you call them as A double dash, E double dash. This is B and D, B double dash, D double dash. So that's how we obtain the left hand view of the solid. Now friends, we will join this AE and BD to this. Similarly, this side also we will join. We will do all this by thin lines to start with. Now friends, we want what is called the position of this point. This is on OC and OF. So friends, you can just draw a horizontal through this where it is cutting, and it is cutting OF here and OC here. So you get two more points there. Here you got A and B. One point is here, other point is here. So you got 4 points. Finally friends, the line or these slant edges OD and OE are cut here. So we will draw another line parallel to that and obtain these 2 points here. So friends, we have got 6 points, 2 on the base and 4 on the slant edges. We will say join all these by straight line. This is by straight line, and again this by straight line. So we joined all these, and friends, these 6 points are there. We will know what to do. We will just draw lines at an angle 40 degrees to the horizontal, and this is what the cut section looks. So friends, let me also join this remaining portion, because the full base of the solid is retained, and this is how it looks. The portion above this is removed, friends. So let us mark or give some number to them. So this is 1 on A, 2 on B, and on C and D. So we can say 1 and 2 here to start with. 1 on A, 2 at B, and OC will take these points. How to obtain these points, friends? It is cutting here, then draw a line from there, bring it to this, so it is cut here. So similarly on the other end you get one more point. These are the 6 points in the top view, join them by straight line. So we got the top view in section. So we will hatch it or section it by drawing lines at 40 degrees to the horizontal, 45 degrees to the horizontal. Friends, we can just marking this name. 1 is at A, so this is point 1, this is 2, and 3, you have to join here, join this is 3, point 4, point 5, and point 6. So you have marked in the top. You can transfer them to the print view. 1 and 2 here, 3 and 6 here, 3 comma 6, and here you got 4 comma 5 on the last slant edges, 4 comma 5. You can transfer them here. 1, 2, this becomes 3, point 4, point 5, and point 6. Friends, this figure in the top view will represent the sectional top view. That is asked in the question. Front view, this figure with the section plane will represent the front view, and the left sectional end view. This is the left sectional end view. I will call it LSEV, or sectional end view. Left sectional end view. Friends, this is how we complete the section of the hexagonal pyramid, and we have been asked to draw its development of the lateral surface of this. We'll call it as part B. This part we want to draw the development. Friends, you know very well, to draw the development of any solid, we need to know the true lengths of all the edges. Here it is a hexagonal pyramid, so we need to know the true length of the base edge and also the slant edge. And if you observe this figure, friend, none of these edges like OA, OB, OC, whatever it may be, they are not parallel to the XY. Since they are not parallel to XY, none of them give the print true length in the front view. So what is to be done? So through this point O, I am going to draw a horizontal line. This is point O. I write a horizontal line through this and taking O as center and this OB as radius, one of these, either O or OB, I am going to draw an arc. Say that arc is going to meet this horizontal turn there. And friends, from there, I am going to mark a vertical line so as to touch XY here and join that point to this apex or the vertex of the solid by this, and this line will represent the true length. Hence, I will repeat, friends, you make one of these slant edges parallel to XY, move it upwards till it cuts the locus or the XY line here. Join that point to O dash. This will give you the true length which is required for the purpose of development. So friends, for drawing the development, I draw a vertical line, say of length is equal to true length. Say this is O, the vertex. Taking O as center, true length as radius, I am going to draw an arc. On this arc, I am going to step up for 6 divisions of 30 mm each. Say this is the first step, second, 30, third, fourth, fifth, and say this is the sixth. So this is the last division, say sixth. And join all these points to the apex. One at the vertex, second, third, fourth, fifth, 1, 2, 3, 4, 5, and 6. So you have got this, friends. After that, see, we are drawing this development, assuming it is not cut by any section plane. Now we are going to have all these base edges joined. See, if you observe this front view, we are retaining all the base edges. So let me join these points by straight lines. And before that, friends, you will have to see from which point you have to start the development. Is it from the slant edge OA or from OB or from OC? That is also equally important, because if you go wrong in this process, the development gets cut into 2 pieces, which is not permitted. So friends, if you observe the front view, the slant edges O dash A dash and that of O dash B dash are totally removed after the object is being cut by section plane. So it is compulsory or mandatory that you have to start the development from OA or OB. So friends, I will take point A, B, C, D, E, F, and A finally. And remember, this is the true length. This last line is also true length. And if you observe the front view, friends, the complete base of this earth is there. Now let us start from this point. The section plane is passing through A and B. So A is one point, B is other point, A is again another point. They are removed, let's see later on. Then these two, OC and OF, are cut here. OC and OF are not true length. So hence I am going to shift it to the last true length line and mark this on OC and OF. OC and OF. So on OC, say here, and also on OF. OC and OF. A, B, C, D, E, F. Yeah. OC and OF. So we are going to have somewhere here, say. We got 2 points there. Then this last line, that is representing the slant edges OD and OE, is cut here, but this is not the true length. Shift that to the true length line and take this measurement from O on OP and OE. So further we have to go up and take this point. Friends, Now let's see how the portion is to be shown down. Here friends, the slant edges OA and OB, as I said before, are removed. So these two will not appear in the development later on, OA and OB. Next friends, you have got, this is OC, OF. On OC and OF, this much portion is retained. OC and OF, that is retained. The portion below that is retained. And after that, on OD and OE, longer height is retained. On OD and OE, this is to be retained. And friends, here, whatever the points you have got in the development are to be joined by straight line. Before that, let me join this point A to this point to this is parallel to X, whatever it may be, and I have joined all the points I have got by straight lines. These are all straight edges or straight lines. Now friends, here you can see this is removed, this portion is retained, and A to F is retained in the development, so we need to have that. I will show this by a full line because the base edges are visible. So friends, again here E to F, EF, that is E and F, edge EF is here, that is also retained, so I will show by a full line. Then ED, E and D, this is also retained, show by full line. DC, D and C is retained, show by full line. And B and C is also available, BC is retained. Friends, here the portion above this is thrown out and this is retained, and we will say this as development of P, where P is this part. And if you want to number them, you can say this is 1, 2, 3.4, 5, and this is on A, it is 6. So there are totally 6 points. You have 6 points in the sectional top view, 6 in the sectional side view, and again 6 points here. And you have to verify whether the solution you have got is right or wrong. In the development, OA and OB should not exist. So OA removed, OA removed, this is removed. And remaining B, C, D, E, F and A and B should be there, but OA should not be there. This is how we obtain the development and sectional views of a hexagonal pyramid as per the given question. Friends, please go through the complete video, and if you like this video, do share this video with all your friends without fear. Thank you for watching my YouTube video.